And Jessica, if there's some questions on the chat, and if I find a spot, I'll stop you and read them, or you read them, and something like that. Yeah.
Okay, great. Yeah, should I have the chat open?
I find it very distracting.
Yeah.
It's up to you. I found some people are able to read the chat while but I cannot. So
Yeah. Okay.
I stop, I read them, and I can pretty much tell you, or this and this question.
Okay, that'd be great. Let's do that.
Oh, Terry's here. Hi, Terry. Long time.
Oh, Terry. Oh, hi, Terry.
That's what I was so surprised.
I know. Terry was with us on a sort of a semi-sabbatical a couple years ago. So. Cool. Oh, no. Not 5 years ago. Oh, my God.
Okay, I'm going to mute myself, but I guess we're ready to go whenever you're ready.
Welcome, everyone, to our IACS seminar. This is actually the last seminar of this semester, and we'll be back in business next February 12th. So put that date on your calendar. I'm Kathy Chute. I'm the Executive Director of the Institute for Applied Computational Science, and I am delighted to introduce our speaker today. She is Jessica Stouth. She is currently a Managing Director in Fidelity Labs, which is an internal startup incubator with a mission to create new fintech businesses that drive growth for the firm Fidelity. She has a background also at several other companies, including Quantopian, where she was Managing Director of Portfolio Management, Research, and Trading. And Quantopian is a crowdsourced systematic hedge fund based in Boston, and actually one of our former project partners too. She's also worked at several other companies. Her background before that was at Berkeley, where she received her PhD in biophysics and did research on computational neuroscience. So thanks very much, Jessica. I'm also just happy to announce that we also know Jessica. She's one of our favorite women in data science. She actually gave a great talk last March 6th, the last day we could actually have talks at our Women in Data Science conference in Cambridge. We'll be holding that virtually next year, also most likely on March 11th. So keep posted, stay posted on that too. So thank you, Jessica. Please go ahead.
Thank you so much, Kathy. You know, it's funny. I was thinking it's too bad this isn't in person because I'm just getting through my C's notebook that you guys gave me. And now, you know, I don't know if you can send me another one or, but I'm at the end of this one. So thanks so much for inviting me to speak to this group today. What I'm hoping to do is sort of give you guys a talk that will be engaging, but hopefully also maybe give you a little bit of the industry perspective, kind of thinking around how data science and computational and quantitative work fits into a corporate and industry kind of structure. And that's something that, you know, I've sort of seen develop through my career. This is a little similar to the talk, Kathy, that I mentioned I gave earlier in the year, but I like to try to give a little bit of a new spin to it. And so I was trying to thinking about how to tie these themes together that I want to talk about today. And a lot of it is thinking about framing these quantitative problems in the right way, which I think is incredibly important. And what I came up with was this idea of how important the why is. So I decided to call the talk Start with Why. I linked, and I have a link in these slides, which I'm happy to share, to really more of a leadership and sort of management train of thought with Simon Sinek. And if any of you have ever seen any of his work or read any of his books, I'm actually not usually sort of a big believer in sort of business writing, but I think he taps into something really fundamental that has to do with motivating good work and motivating other people to do good work. So hopefully that will work and you guys will sort of follow me through it. All right, so why ask why? after I wrote this and put it on a couple slides, I'll date myself. I think this was a Bud Light commercial at some point, but why ask why? So the thesis in Simon's work, if you go and take a look at it, is people don't buy what you do, they buy why you do it. So the first reason that I think starting with why is foundational to doing good quantitative work is that you need to inspire people to believe in the work that you're doing, that it's important, and that there's a reason they want to follow it. So you are selling your work to the rest of your company when you're doing work. And it applies, a lot of his work, he talks about, Apple is a great example. Apple's not a great computer company. They're a company that inspires people to think different, be different, and be unique. So encourage you to go check his work. But now that felt a little fluffy for a data science talk and a group of this type. So I came up with another good why, ask why quote from Benjamin Franklin. And actually, when I found this, I was like, this is just too perfect. This is sort of the other side of the coin of where I think this motivation is so powerful. So I'll read it. Highly competent people search for new ways to keep learning, growing, and improving. They do that by asking why. That's probably what brings you all here today. But after all, the person who knows how will always have a job. The person who knows why will always be the boss. So if you take one thing from this talk today, please take that you should keep asking why. And if you do, you will end up being the boss. Maybe that's where you want to end up. All right. So thought I would take just a couple minutes to sort of talk about my own history with asking why. But you'll sort of see through a little bit of this that there's a lot also of learning how. And I will apologize for that I'm not in presentation mode. I can't figure out how to make the animations work or not work. So here we are. All right, so my background, Kathy mentioned, I really have crossed a path that started from a very basic research standpoint. So spent 5 years out in Berkeley studying. I joined a biophysics program, but I really ended up working on computational neuroscience. And there, really wanted to ask sort of, why does the brain work the way it does? Why, do we experience things the way we do? There's why and there's how in there. And there's a lot that I think is foundational from a really solid basic research background that's incredibly powerful in applied sciences. So I want to talk about that. So in this, timing wise, for those of you who were around in the spring of 2008, I got my first sort of what I call private sector job, or, whether you want to call that a real job. And, little did I know that in the fall of 2008, we would have the great financial crisis. So that turned out to be fortuitous timing in hindsight. And I really went over that time period from basic research to applied research. So taking what I had learned about studying how to create models that might represent how the brain is working and translating those into models that might represent how the stock market is working. And so I worked on doing stock selection models for a company called StarMine. That company got bought. So another fun thing that happens in the corporate world is companies buy and sell each other. So that company got bought by a larger data company called Thomson Reuters. I went across those years from 2011 into 2013 from just being in my own little corner thinking about how to build a model that made predictions into thinking about how those models and the tools that researchers use to develop those models could be sold as products to other researchers like myself. So that was a really interesting career point to move from just thinking about research and modeling. And I was doing mostly time series modeling into thinking about, hey, how does data research modeling tools, how are those things used to drive successful asset management businesses? Those were the customers of this company that I now worked at. And so I started to have a little bit of a bigger lens in thinking about how research drives profits for companies and how that can become a business. And like Kathy said, from there, I went to this company called Quantopian. So this is also a story of sort of going from an academic environment to a startup, to a massive 40, 50,000 person company, back to a 7-person startup, back to a 50,000 person company. So I've had the opportunity to sort of hopscotch back and forth from that really small academic environment and then small startup environment into a really large corporate environment. And that's provided a really interesting perspective because, of course, I was doing pretty quantitative work across all of those different environments. I'll talk a little bit more about some of the examples that I want to talk about today. Draw from the time that I was at Quantopian. And there's some examples that are pretty different whys that we did while we were at Quantopian. And then last summer, made the move from Quantopian to Fidelity Labs. So like Kathy said, Labs is a small fintech incubator unit inside of Fidelity. So if you're familiar with Fidelity, it's a very large asset manager based in Boston. And the company has been around for about 75 years and is privately owned. So our CEO is the 3rd generation manager of the family owners. So it's a really interesting place to be inside of an incubator, inside of such a well-established and sort of long tenured company. And we're doing some interesting work there. I will talk about that sort of at a really high level, but feel free to ask me about that also in the Q&A. All right, so the next way that I want to frame this is to now kind of think about those two worlds that I've had the opportunity to cross between, and maybe this resonates with some of you, are either have crossed between or are thinking of crossing between these worlds. And I think it's really important to look at basic and applied sciences and recognize that they have different why statements at their core, right? So when you're doing basic science, basic research, your why statement is to actually advance the knowledge of the world, right? So if you're going to publish a paper or do your dissertation, you're making the statement that that's original research, that you found something new out. It's a very intimidating statement to make when you're in grad school and you're trying to do original research because it sort of feels like everything's been done. But that's what you're trying to do. And those insights that you generate from your work, they may or may not have readily observable applications. And there's really incredible value in those insights, even that don't immediately have readily observable applications to them. I probably don't have to convince this group of that. So that's fantastic. Now we're talking applied science. Applied data science, or just applied science, maybe more broadly speaking, the why statement there is different. So the why statement there is, yeah, I also want insights, but those insights have to be usable either by me or by analysts, business users, leaders of the company, to translate into tangible business value. And if you're in an applied field and your work is not creating business value, you may get away with that for a while, but you're not going to meet with the kind of success that is where you really want to head, is my position there. Now, I will say that across my career and in my experience, I believe that these two different regimes are coming closer and closer together and are often operating in a little bit more of an iterative loop. So that there are times where something is being learned that is new that can be very quickly applied, or times where applied sciences are pushing the boundaries of us thinking about what is possible. And also sort of part of the thesis of this talk is to think about, or get you guys hopefully to think about, some of the same principles that we use when our why statement is learn something new about the world are very valuable to use in the business context where we want something to have business value. So it's not, even though I've said up here, right, that these are two different why statements, there's a lot of the skill sets that you get in learning how to do high quality basic research that are extremely valuable to you down here when you're looking to create business value. All right. So here we are, we're in an applied course and we're thinking about applied data science. Business value is why we're here. This is a real adjustment for scientists who come out of a scientific background into a professional career. Easy to say, say it over and over again, and evaluate everything you do against this metric. It's really, really, really easy to lose sight of it. All right, so what are some examples of business value? Generating investment returns is one. Selling a product is one. I'm going to argue customer happiness is one. That's pretty aligned with the start with why ethos of this talk. So I'm going to talk a little bit about the first one, just because there I can pause and give a little bit of a specific example from my own career. So it's pretty easy to see that if you're working for, let's say, a quant hedge fund, that if your data science work, your modeling, your predictions can generate outsized, let's call them risk-adjusted returns, that's of business value. There's a very clear relationship where your company, let's say, is responsible for investing and managing assets, and how your work is measured is going to be on the returns that are generated. That's a goal that we had at Quantopian, and the modeling that we did there. I'll share some of the lessons we learned, was that simpler is better. We were working on trying to combine predictive signals, which we decided to sort of think of as weak predictors, across thousands and thousands of people had written trading algorithms that would pick what stocks to buy and sell in a given day. And so we had a data science problem, which was of the shape of, all right, you've got all these different little algorithms that are telling you signals about the stock market every day. And your job is to try to synthesize that all together into a single investment product that's going to pick what stocks to buy and sell and how to make money. And the first version that we ran of that was to look across all of those individual little algorithms and try to basically do an analysis to say, which ones of these weak predictors, which ones of these widgets are really working, and which ones should we sort of turn off? So we looked at it like an idea of sort of picking winners amongst this. And what we realized when we actually ran with that was that we were ending up with something that was unintentionally really complex. We were needing to basically run a portfolio of portfolios. And each individual little portfolio of buys and sells could potentially be wanting to buy and sell the same stocks that its neighboring portfolio was wanting to buy and sell. And that's not an efficient way to do things. So what we did was to look across that and realize that we could turn it into a data science and a machine learning problem, where we could think of these individual signals, again, as I said, sort of weak predictors, and look at a way to try to train a model to go across time and figure out how we could combine and add these signals up on a single stock level. So while we before might have been saying, great, let's run a portfolio over here, we're going to buy Apple and short Tesla, and over here in another sleeve, we're going to buy Tesla and short Apple, we realized we had a way to combine these things all together, simplify, and end up with one portfolio, which was sort of had the benefit of all of those signals in it. I will say that while that worked a lot better, we did continue to figure out that the simpler we kept our models, the easier it was for us to understand how things were working and the more success that we met with. I think I'll kind of come back to that theme a little bit later. Sales is really obvious. The one little reference that I want to make on the customer happiness front is at the end in the slides, I have another sort of business book recommendation. I can't believe I'm doing this to you guys. But if you haven't come across it, the core philosophy of Zappos was optimizing on customer happiness. And the Zappos founder and CEO, Tony Hsieh, wrote a really fantastic book called Delivering Happiness. And he talks about how his organizing principle from starting the company was making every single decision based on thinking about whether that would make his customer happier or less happy. And that was his why, was that people should be happy when they interacted with his company. They order something, you get what you want, as fast as humanly possible. Maybe there's downstream implications of that we're all realizing now, but you're happy. You're unhappy with your product. You want to return your product. That should be super easy. I like this one as a business value, even though I think you could argue that now you create a measurement problem for yourself, and you got to really think about how you're measuring whether or not your customers are happy. But it's a really compelling why statement that also gets at that sort of leadership principle of, if everyone in your company is knowing that they're coming in every day to try to make sure their customers are really happy, then that's like a very sort of positive why statement, right? Whereas, driving investment returns and sales, those are really great things, but there may be a little less sort of day-to-day motivational for teams and maybe for data scientists. Okay, so I want to talk about a couple of more types of business value statements. Operating efficiency, speed to market, and customer engagement. I will say that, so by speed to market, what I mean is if you can create a model or a process or a set of tools that might be machine learning based, where you've reduced the development time or the time to building products, and you can get something out into the marketplace faster than your competitors because you have that advantage, that's incredibly powerful. Same for user engagement, although you have to be careful not to destroy democracy while you're doing it. We're learning about watching out for that. Operating efficiency, I think, is the sort of unsung hero here and the sort of elephant in the room. So I think lots of you are learning about automation and machine learning and AI models. And while we all know that the end game of that is not going to be replacing, every human in every company, at the end of the day, the truth is that you will be making things more efficient. And operating efficiencies are extremely important in industries that especially start to become more mature, and industries where there's competition. And asset management is a mature industry where there's a lot of competition. So when I look, not to speak necessarily for Fidelity, but when I was at Quantopian and had the opportunity to talk, oftentimes at conferences or broadly across with other peers at much larger asset managers, we often talked about the challenges of using machine learning or artificial intelligence to really do time series predictions. And that's if I go back up here, right, if I want to actually generate investment returns, my models are probably time series models that are making predictions about how stocks or some other assets going to behave in the future. And there's a couple of reasons that's extremely difficult to get to work. One reason is extremely low signal to noise in stock market data or in financial markets data, and the other is non-stationarity. So making these time series predictions when you're not learning underlying fundamental rules of physics, but what you're doing is observing the emergent properties of a bunch of behaviors of people driven by regulations, and those things can change, and they can often dislocate and change at the drop of a hat. This is really, really, really difficult. I'm not saying there aren't people who are successful with using machine learning and artificial intelligence to make outsized investment returns. There are. A lot of times where that's happening is at really, really, really short timescales, where anyone who's ever worked in predictions knows the longer out the prediction is, for a long ways, it becomes more and more challenging. Maybe, you go out in sort of infinite future, it becomes easier again, but there's like a long, hard hill that you climb as you're trying to make forecasts that are good for the course of, say, days or weeks. If you're trying to make a forecast of what's going to happen over an extremely short time scale, like milliseconds or microseconds, it starts to become more and more doable with a lot of computational power. So one spot that this kind of work does work really well is in high frequency trading. So if you come across that area, there continues to be a lot of work being done there, although it does become a little bit of a hardware arms race because you're just basically trying to be faster and faster and faster. So back to operating efficiency. Operating efficiency is different. Like, let's take an example that is a good ML example where I was previously hiring dozens and dozens and dozens of folks to work in an offshore data center, sorry, not really a data center, but an offshore data acquisition facility where people are going to be reviewing financial filings by hand and reading footnotes and extracting information from those footnotes and putting it into tabular form because I'm a data vendor. That work is now all being automated. So through the combination of natural language processing and machine learning, we can take a training data set where people have read a bunch of footnotes in financial filings, and they've extracted a set of important tabular information that you can then just go ahead and process forever, right, in an automated fashion, the rest of those. So now you've got an operating efficiency. Now you've reduced a cost somewhere in your value stack, and you can take that capital and redeploy it somewhere else that's of higher value. You maybe already redeployed it to AWS fees. We don't know. But operating efficiency, I think, is one of the most important business values that applied machine learning and AI is bringing. I didn't put on here, there's another one I think, which is sort of robustness, but these are the main ones that I wanted to chat a little bit about. So these are your whys, I think, is what I'm trying to get at. And I think when you're working in your first, second, third job, you should wake up every day and know, and if someone asked you, be able to say, which of these 6 things is your why statement, or what's your version of that why statement, that if you make that thing true, you're going to be successful. All right, so now I want to talk a little bit about some of, I guess, what gets into how. So once I know what my why statement is, I want people to buy my product or engage with my product or feel happy when they use my product. I'm focusing on those. I didn't give examples here on some of the operational efficiency or the investment returns, but let's pick sort of those consumer product facing kind of whys. So these are some examples that I didn't work with at Quantopian, but I've seen a lot more now that I've been thinking more about the fintech ecosystem more specifically. And I think these are kind of some nice, clean insights that can come out of data science work that can be really powerful. And knowing which one you're going to try to create ahead of time and then testing whether that's working, I think is really important. So one example might be a next best action. That could be a model that's being built to automate a sales process. That's somewhere that we've seen a ton of value being created. Sales is obviously a powerful why statement. Make my sales force more efficient. And a next best action is a type of insight that tells your salesperson what they should do next in a sales process when they're working with a client. And it turns out that if you've got a process where you have many, many salespeople, and you can get them to sort of write down what they're doing over time with their clients, you can find ways of basically taking good salespeople and training models to teach all the other salespeople how to act like the good salespeople and know what action they should take next. Another one we're all probably pretty familiar with would be product recommendations, right? So Spotify telling me what I want to listen to next, or Amazon telling me what I want to buy next. And then a related one is sort of probability of a purchase. Actually, probability of a purchase, that one I've gotten really interested in lately in my work inside of labs. So it related a little bit to thinking about the automating sales channel. If you think of a use case where you're going to be spending marketing dollars to put your product in front of consumers, then what you'd like to do is optimize putting your marketing dollars to show that content to the person who the activation energy to get them to buy your product is as low as possible. So there's a lot of interesting work in thinking about how could I go out there and look at consumers and think about who among a set of consumers would be most likely to buy my service, and go after them first and sort of let be the folks who are least likely to purchase my service. All right, so now we get to some of my favorite pet peeves, I guess, although I hesitate to ever write forget who it was who had some great talk on like my top 10 peeves. I think it was like Cliff Asness, who was a quant at AQR, who gave a whole talk on his pet peeves. So this is not that, but this slide does sort of touch on some of my pet peeves. So once you know your why statement, and now you know your how, sort of what you're going to build to try to create an insight that's going to generate that business value. There's going to become a point where you're getting some insights that are coming out of your work. And then these are some really critical questions to ask yourself. They may sound simple, but I will tell you, very many smart people breeze right past these questions and present insights that don't meet some of these criteria. So does it make sense is my favorite one. I think we can all get into the weeds, into precision and accuracy and recall and deep into statistics. And it's really easy to lose sight of an extremely basic sanity check. In the does it make sense category, I'm a huge fan of thinking of the absolute zero order, dumbest possible, simplest benchmark you can think of, where you kind of know what ground truth is. And then looking at any model that you create as needing to exceed that model, and seeing if it sort of follows common sense and having things that check in there. Is it valuable? If you've got a good why statement and you know what you're supposed to be creating, then it sort of should be valuable. But it's great if you generate an insight to also think along with it how you're going to collect data about how that insight is being used and whether it is actually really being valuable. So if we think back to the use case of like a next best action in a sales process, can you then get that product team to instrument data collection that will keep track of whether that next best action that you had recommended was successful and led that salesperson to having a higher probability to close a sale. Same thing, obviously, for a product recommendation, or a probability of purchase. So is it valuable can both be a question you ask once and a question you ask over and over again. And sort of the logical extension of is it valuable is really become sort of a learning process, actually, if you can automate it as opposed to just sort of asking it of yourself. And then is it easy to use? If you have to spend 90 minutes and 40 slides explaining your insights, then it is not easy to use. So is it easy to use? I'm encompassing in there, is it easy for you to explain it to someone who is not a technical expert in your same field? So when you're in an applied setting, you're going to be working in cross-functional teams. I think I talk about this in the next slide, so I'm not going to belabor it here. So is it easy to use? Should be really simple. That would be the other, if you go away with one thing from this talk. Keep it simple is the thing that I have learned over and over again in my career. Every time I simplify something, I'm happier. Every time I let something get more complex, things start to become more confusing to figure out, I guess. All right, so great. You followed me this far. This all sounds super easy, right? You already know your why statement. You already know what kind of model you're building. This is a piece of cake. Okay, well, here's some of my favorite. How can this all go wrong? And I've earned all of these, and apologies, I'm not animating them, I'm showing them all at once, but you can maybe guess that I want to start by talking about data. So I think I have had talks in the past where my whole talk was on the love-hate relationship that we as quants or data scientists have with data. So we love data, we hate data. We need data, it always disappoints us. Sort of knowing as you go in to any applied project that it is extremely unlikely someone's going to walk up to you with a silver platter and reveal to you this beautiful tabular data that's been normalized, labeled, and laid out for you to drop right in the top of your model. It's going to be hard to get data. It's going to be hard to combine data. It's going to be hard to normalize data. It's going to be hard to understand the provenance of that data. It's going to be hard to know when you'll get the data again, and if you can repeatably expect to get the same type and shape and kind of data on some regular basis. And if you're buying data, now you got to deal with your counterparty at the data vendor, and they're going to charge you way more than you think they should for data. We love data and we hate data. So I can't say enough about that. Communication is another place that this can all go wrong. So effective collaboration and communication between data scientists, analysts, and business users can be a big challenge. I would underline that like 10 times. I have found when there's a way to get a great cross-functional team, when you can really all speak the same language, and part of that is removing any sort of jargon from your presentations, and explaining in the simplest possible terms, why did I do this? What was the insight that I set out to generate? And then communicating what you found and what the insight was and why that is important, and drawing that really clean circle is extremely powerful. And I know that in my own career, there were definitely times where I felt like this should be so obvious. And I think part of that could be you come out of grad school where you've been with folks that think about things in a similar way and have been trained along with you, and you all have a really strong common shared language, and you can use shortcuts in terms of the way you talk to each other, and you sort of like understand a whole set of priors that you bring. And when you are now in a cross-functional team, you're trying to communicate with folks who don't know what you're talking about, and it can be sort of easy to be like, well, that's their problem. I have a PhD. I know what I'm talking about. I'm over here like creating great insights that will drive business value. That's so great. If no one else can understand what you're talking about, it's not actually going to drive business value. And so I think it has been something that's taken me a long time to really, and I'm sure I'm not, life is a continuous journey, but to really reframe and think through that it's your responsibility to translate your work into a sort of universal language that other folks on your team and all the way up to whoever runs the company that you're working for should be able to understand what you're doing. So I can't stress that one enough. Okay, there's so many in here that are fun. I won't belabor the nerd sniped. It's easy to mix up what to optimize on. Your job is not to produce the most accurate model. Pause on that. Your job is to drive business value. So if you can drive business value with a 80% good enough model, and then move on with your incredible intellectual horsepower to solve the next problem for your company that also drives business value, there are times where that's better than spending another 6 months improving your model accuracy. So you're not optimizing on model accuracy. I know that's a little bit of a controversial statement, but I'm going to leave it there. I already talked about predictions are hard, especially about the future. Anytime you can take a prediction problem and make it easier on yourself by doing really basic things like, I remember one model that we built at StarMine was a model based on looking at a bunch of analysts. So analysts rate stocks and say whether they think people should buy or sell stocks and at what prices. And this is called sell side research. And so you can have a data set where for a given stock like Coke, you sort of have a survey of what all of these professional analysts think. And what a lot of folks use is the consensus estimate. So data providers take all of those votes by professionals who are paid to make them, and they add them up and they give you the mean. And we created something called the SMART estimate when I was at this company, StarMine. And I remember getting there and I'm like, my first job was to come in and like understand the SMART estimate model and how we built a prediction that was better than the consensus estimate and update that white paper. And I did all my modeling work. And I go through sort of seeing about what all the different steps of modeling would improved the quality of that estimate that was the SMART estimate. And we kept track of what analysts were more accurate over time. And we did all these really smart things. And I was looking at what is the sort of, we did these waterfall charts, which thing that we do is contributing more and more and more to the predictive value. And let me tell you, excluding excluding stale and obviously erroneous data, which was off by like more than 2 standard deviations, was the largest single contributor to the predictive quality of that model. So have respect for how hard predictive models are and take every cheap, low-hanging fruit advantage you can get with improving the quality of your model with that. So never underestimate how hard it is to predict the future. And then the last one, I've harped on this a little bit already, is speed. So the time that it takes you to deliver your insights, that time is your enemy. One thing I like to say to my team in labs is, once we know a thing that we want to get done, so whether that's an insight that needs to be generated or some milestone that's between us and generating that insight, get something really simple, really defined, then I like to say, all right, that's where we want to go. How do we minimize the number of days between today and that day when that thing is done? How do we minimize that? Are there any days we can take out, right? So if there's a day where we're going to go check this other thing, but really we could do it after that key milestone, great, push that after that key milestone. This is so important. At Fidelity, we have a leadership principle that's pace over perfection, which I do believe is a little aspirational. Fidelity is a lovely place, but it's a very thoughtful place that does not move fast and break things, and as well we shouldn't. But this is really, really important. And I've seen a lot of really brilliant data science folks get stuck in this spot where there's always one more thing you can try to improve the quality of your model. So maybe adhere to the computer science and the software developer side of yourself and just ship your code, look at how it works, and move forward with your life. So I can't emphasize that one enough. Now here, this is really right at the end. I'm going to let you guys ask me questions. But here's where I'm trying to tie this a little bit back into that interplay that I see between basic and applied science. So as you're doing all of this great work and you're avoiding all of these pitfalls and you're moving quickly and making decisions and creating models, I'd also just want to remind you to go back to those basic principles that you learned all the way from high school science on up. To think through. And I found somewhere, that these are sort of the 6 basic principles of doing basic science. So some of them I sort of end up using more than others, but they're all pretty awesome, actually. So extraordinary claims require extraordinary evidence. I actually was just talking to someone today who mentioned to me these really smart folks who were working on an investment strategy. And they said, yeah, it's 24 or 25% returns year over year with virtually no risk. Okay, so this colleague and I looked at each other and we were like, that's probably not true. That's probably not. I mean, it could be true. It certainly could be true. It could be. What instruments being traded, how, whatever. That's an extraordinary claim, which would require extraordinary evidence. Let's look at it. I learned that also really early in my career. One of the first trading strategies I was researching at Starmine was like an option something or other, and I didn't know anything about options. And same thing, it came out looking so good, okay? And I'm like, wow, this is just awesome. Like my first thing, and it looks so good. And oh yeah, I found like a date alignment problem where my model had look ahead bias, and it was just trading on information about what the prices of those options would be in the future. And that's also a very profitable trading strategy. So I love that one. Falsifiability. So if you find something, can you sort of prove the opposite? Can you figure out that you would have found the negative answer if that negative answer would have existed in this data? Simplest explanation is always the best. I live by that. Replicability. If you get a similar data set from another source, how close or not does it look? If you change your data set just a little bit, right? If you're, there's a lot of statistical techniques that you can get into for replicability. Rule out rival hypotheses. And, this is like the worst one ever is, correlation is not causation. We could probably all use a reminder on that all the time in our daily lives. And while these 6 things, when you look at them here, sound so obvious as to be silly, I will tell you that if you print them out and tape them to your desk or your wall of your cubicle, or now your home where you do your work, and you sort of continue to just sort of do like a little quick mental checklist of like, is this too good to be true? Could I tell? Is there a simpler way to do this model? That's almost maybe my favorite one for data science and machine learning. You will find that you can pick things out and catch your own work sooner than when maybe your boss will catch it, or maybe your business value won't work out the way that you want it. So that's what I wanted to run through. This is my low resolution Halloween themed thank you slide. I'll distribute these slides if I'm able to, and I did put links to the TED Talk and the Zappos book that I mentioned. So with that, I'd love to answer any questions.
Thanks, Jess, very, very much for your talk. That's great. You actually have one quick definition of Occam's razor. Someone just asked about that.
Oh yeah, actually that's perfect. Let me minimize, because I wrote down a definition of Occam's razor so I wouldn't have to remember it. All right, so the one I had was, if 2 explanations for a phenomenon are equally good, we should generally select the simpler one. And there's some Sherlock Holmes version of it, I feel like, but these are all good. I mean, I found these on the internet, folks, so I'm not coming up with them myself, but I thought they were really nicely. So I sort of started with the ones I was thinking of, and then I was like, there's got to be just like a nice exhaustive list of these. Yeah, there is, turns out. They're all quite good, actually. For a claim to be meaningful, it must be falsifiable, capable of being disproven. That's like a good one. Actually, that's a really hard one, I think. Okay, so that was a short question.
Kathy, you're muted.
Almost go ahead. If you find some questions, yeah, go ahead.
There are only people are agreeing with you, Jess, most of the time, especially on communication and a couple of other things. I agree. Same for me as a couple of times. I think a lot of the audience were agreeing with you, but maybe we should ask the audience for more questions now.
I was curious about one thing, maybe just if you have some examples just on your current work with Fidelity of really good applications where it's worked well, where all these things that we've talked about, the why works, the business value works, and the product or whatever it is working, and where machine learning plays a big role. That would be great.
For sure. So, and let me just, I'll try to speak at high level, because I think that there are things that I have seen in the sales automation front. This next best action is a great one. There's a model that I got the chance to work a little bit with that looks at basically, so Fidelity creates funds, and that's the asset management unit, and we call that manufacturing. And then there are 3 different distribution channels: retail, workplace, and institutional. So I've done a lot of work lately with the institutional business, and they are selling those funds and maybe other services or model portfolios to intermediaries who are going to then work with clients. So that's an interesting situation where we're trying to figure out for a given wholesaler who would cover a range of advisors they could speak with, how should they think about who they should be speaking with in what order and what day. And there's an internal machine learning model that got built to basically, so that those folks would come in every morning and open up their desktop or their laptop and say, all right, these are all the people in my coverage universe, and here's who I should call first, and here's a suggestion of what I might want to talk with them about. That's a really nice example. And now I will say also highlights where there's a thing that can be tricky. So I was talking with the folks that deployed that model and said, oh, this is so cool, this is a smart application, and you had historical data about what worked and you were able to train it, and now you get, and they said, yeah, it is great. But basically there, where it's working well with business users, the salesperson who's trusting it and engaging with it, and then providing feedback and actually taking the extra effort to go into that system that recommended them the action and say like, yeah, that worked or it didn't, and here's a note. And that the easier they could make that to use and the more they could drive that adoption, the more powerful it would be. But that you can put out there the best recommended AI prediction ever, but if your business user doesn't trust it and doesn't want to use it and does whatever they were going to do anyway, then you're sort of like a tree falling in the woods. So that's one example that I would give. There's other stuff I have had less direct expertise or exposure to, but Fidelity does a lot of amazing work in operating efficiencies around call centers. So Fidelity employs like 50,000+ folks across the globe, but a small fraction of those are the investment professionals, right? That work mostly out of Boston. And so there's lots and lots of folks working in call centers. So automating and smartly routing calls to call center folks. There's some cool voice print technology. There's cool stuff that's been done in the anti-money laundering and risk space. And that's not even just within Fidelity. I know, Kathy, you mentioned there was the AI in the Enterprise Day that I did at Harvard last year. And one of the great examples I saw there was just looking at, creating machine learning models to do fraud detection. And that's not something I've had experience with inside Fidelity, but that's a fantastic application. And again, what's nice about a lot of these, common to some of these applications that I'm mentioning, is there are things where you can use a lot of pattern recognition and you're not completely stuck with this problem of sort of non-stationarity that you get in time series. So, I continue to see that sort of, when you find use cases that don't suffer as much from that non-stationarity problem, and then use cases where you've got sort of a lot of consistent data, those I've seen work well. So those operating efficiency type ones I've seen work well.
Great, thanks.
There's another question for Vasant. Vasant, do you want to ask the question? Okay, you can read it, or it said, do you think academia tends to overemphasize on accuracy of the models, if not reproducibility, and how that hampers progress in scientific breakthroughs?
Yeah, I don't know if it hampers progress in scientific breakthroughs. I think it's a challenge for folks who go from academia into a business setting. Although I did see, and I come from really more of a science than a computer science background, right? So I'm a little bit of a tourist when I speak on the computer science side of things, but I have seen some that seem perfectly reasonable to me, papers and sort of articles pointing out that in the field of machine learning, there is a real focus on, ever chasing sort of better statistics. And I mean, I'm sure like Pavlos here, I'm like saying this in front of you, like a million times better than me, but this rings true to me that, geez, is that the thing of value to just be chasing the ever more complex model that sort of ekes out a little bit of advantage? Or would our time be better spent looking at, are these models that are really great, are we applying them correctly, or are we missing really great high value use cases that they could be applied to? I think that's a really interesting area. So I'm sure you know more about that than I do.
My opinion is both. I think there is a little bit the last few years chasing the last 0.1% of the accuracy, but there are a lot of folks that they also do the other part, trying to dig in deeper into understanding. And so I think it's happening at both fronts, at least my opinion here. So there's another question. From Cactus, what are your measurements for customer happiness or satisfaction?
Yeah. Oh, that's a great question.
We call them Q scores here.
Okay. Yeah, that's a great question. And I'm trying to see, let's see if I can see the chat. I can't see the chat, so I'm going to let you read them to me. Maybe if I stop my sharing. Oh, there we go now.
Yeah, you can see them.
Okay, great. How do you measure customer happiness? Yeah, I mean, so I think that is a great one. I'm working on a product right now that's not in the market, where we're thinking about how to collect feedback. Some things can be super simple so that let's say you have, a web product that folks are interacting with, you sprinkle little feedback places throughout the product where you're asking them to say, hey, was this prediction accurate or not accurate? And you're actually just directly asking them for feedback. We are all probably being asked for feedback all the time to fill out surveys and rate things 1 to 5 stars. And so all of those are sort of ways that you can really directly try to measure if your customer is happy. The other things you can do are measure when your customer is unhappy, and try to check that and then sort of hope that your silent customers are happy. But I think that is important, actually. So being able to collect feedback on what's not working. If you're in some sort of a model where you think you're improving customer happiness and you're in an environment where there is a call center, for example, maybe those are the more mature businesses, but for example, Fidelity has call centers, and it's possible all the calls are auto-transcribed or transcribed by a transcription service. And it's actually possible to go through them and get a signal of, how happy or not folks are. And what's done in the consumer analytics part of the firm, which is not where I work, is a ton of really cool work around sort of tagging those conversations with topical tags. And so you then, I think, can kind of measure if you're actually talking to your customer. So I think there's a lot of ways that you can do it. The other one that I like is, it's a little bit maybe more lagging, but I like the idea of saying, well, like my customers are happy if they're repeat customers. So also being able to have some sense where there's a way to sort of see if a customer is progressing through a funnel, that if they're progressing through the funnel, sort of hopefully they're happy. That's not perfect, but I think it's often true that you'll hear if they're not happy. Let's see. Does data science mostly, in the investment world, does data science mostly result in correlations rather than understanding the causes? So there are, and there I think you're saying sort of investment data science, meaning what I'll kind of call quantitative finance. And broadly speaking, there are sort of two schools of thought, and they can both be inside the same broad investment strategy in quant finance. So there's fundamental and there's sort of technical. Fundamental is where you're working from the fundamentals so that you are really trying to understand the causes. You're trying to use things that you know about how the investing world and your corner of it that you're trying to model might work. And you're really trying to build a model up from that. So you're using things like the example I gave with an analyst model, right? You're saying, well, analysts on Wall Street learn a lot about these companies. There's information content in that their prices that they recommend and their buy and sell signals that they recommend. And while that's really public, if I could investigate those and understand them at scale and look for changes in them at the edges, maybe I could create a signal. And that is a fundamental. There'd be a real reason why you'd understand why that would be done. And so there's a lot of work in that area. The other area, technical, is where you're much more just looking to see what the data is telling you and looking for patterns and statistical properties. Now, those can work for a while, they can persist for a long time, they can go away. It becomes extremely difficult in that sort of pattern-based and technical-based analysis to separate out which ones might have true causes underneath them that you're not sure what they are, and which ones are just apparent. And what I would say in that second area is, while I think when I started out, I was very dismissive and looked down upon all of that kind of work, it became clear to me that just because you couldn't know the why didn't mean that in some cases there wasn't a why, and that there were persistent things that could be found with statistical techniques. Folks have been very successful with that over the years, finding investment strategies based in statistical techniques where they didn't start with a prior, which is counter to my own, way I would traditionally approach projects. And so it's really tricky. And what usually is done is really to say, okay, you think there's a why. So you take some amount of risk, you basically employ a strategy where you put a little bit of risk on a statistically based signal. And if it's working, you sort of slowly give it a little bit more leeway and a little bit more weight, but you're really trying to sort of let, it's tricky. It's really tricky because when something's working, you can keep wanting to put more weight on it. When something stops working, it's really hard to know when it's transiently not working and when it's gone. And so that area of kind of thinking about how much to trust different types of signals and how much to weight them is one that there's just like no right answer. And I would say folks are continuously trying to work on. And I think I think it seems like I've answered most questions, and then I think we may be at time. So I'll let you cut my mic, Kathy, if we're at time.
I think we're great.
I have one final question. So this is mainly time series models, and these time series models have become quite complex the last few years, last 2-3 years, right? So we have BERT-like transformers and the whole thing. Yeah. So are you coming to the, at one point you have to decide how much you want to know why, how much you want to have good results. And the tendency the last few years is that the why is becoming harder. I mean, the wonderful models, but it takes a little bit of time to understand what's going on. I mean, why 8 heads? Why this? Why that?
Yeah.
There's that why. There's the why is working, and there's why this particular architecture works. So how do you go about it in industry that you, at the end of the day, you have to get results too, right?
Yep. So I think that the way you answer that question depends on a couple of factors. So basically, if your prediction is wrong and you don't know that why, how bad is that? So maybe when I'm serving ads, it's like not bad at all. But if I'm investing, $1 billion here or there, it's real bad. And maybe I also think it's real bad if I can't say why, but maybe regulators think it's really bad. So I think there's a regulation component that's in the asset management industry. And let's say that's not even an investment model. Let's say it's something like what I'm working on right now. One of the things that we've been playing around with is, can you make, and this is like, folks are doing this in the public domain. I'm not doing anything secret. I just think it's an interesting spot. Can you basically use AI to detect and identify someone's personality? And like I learned that it's like super doable. What becomes tricky is how much text or voice or how much of them do you need to make a prediction? And the more you want to really do it quickly and squish that down, the more impactful some of these models that you're mentioning that I don't know a ton about, but right, these real smart folks working for me are like, oh, here I need to use this BERT transformer model, and I can do this cool data augmentation with Google's AI and translation, stuff, and all this really, really cool work. And I'm like, oh yeah, great, okay. And this is kind of like low penalty too. Like if I'm wrong about your personality, like whatever, it's better than nothing I didn't know about you. Well, now we're thinking about if we turn this into a product that goes into the market, we have like legal risk and compliance, where if it's part of something that's even under an umbrella of Fidelity at all, I will have to go through an algorithm review board, and that algorithm review board will want to talk about my model explainability. And in my legal risk and compliance, folks will want to have, a paragraph on my website that says, hey, here's why this is reproducible. Here's why I'm not profiling you. Oh, by the way, I literally am profiling your personality. So, I think it's so application specific how to answer that question that I won't even go into, sort of my philosophical thoughts on how you might answer it. I'll say I think it can be often defined by what that application is.
I assume it's only legal, it's also ethical sometimes, right?
Well, that's the thing is I feel like before you even get to the ethical considerations, I'm in such a highly regulated industry that it almost stops me sooner. But I think you're right. Places where it's not regulated yet, and companies that are not so closely regulated as the asset management industry, then they're really asking themselves, they're sort of self-policing on that front. That's definitely the frontier of that, I think.
Thank you, Jessica.
Thanks.
Great. So I think we're about to wind up. Thank you very much. Really appreciate. Great to see you, Jess, on screen, and really appreciate your time with all of us today.
Thanks so much for having me.
Great, great. Thanks, Pablos.
All right.